Hello everybody, I'm Chetan Arora from University of Luxembourg and I'm going to present to you RUBRIC, a flexible tool for automated checking of conformance to requirement boilerplates. Here's the agenda of this presentation. I'll present to you the motivation behind building this tool, followed by the overview of RUBRIC, all the processes going behind and the functions provided by this tool. Then I'll walk you through the RUBRIC tool. We'll get acquainted to gate interface in which this RUBRIC tool has been built, and then the two main functions provided by RUBRIC, that is boilerplates conformance checking and natural language requirements best practices checking. Then I'll conclude this presentation with some results from a case study we conducted using this tool. Here's the motivation behind building RUBRIC. Well, natural language is the most common medium of specifying requirements, because it's easy to understand by all the stakeholders. But despite this advantage, natural language is prone to ambiguities, and it's difficult to do automated analysis on natural language requirements because of the lack of adequate structure and complexity of unrestricted natural language. One solution to address the cons of natural language requirements is to follow a certain template, or boilerplates as we call them. Using boilerplates mitigates many types of ambiguities and makes automated analysis easier because of the structure and preciseness they bring to natural language. When requirement engineers are using boilerplates, one important quality assurance task is to check if the requirements actually conform to boilerplates, and doing this manually is very difficult because of the large number of requirements in the projects these days and the fact that requirements keep on changing during the course of the projects. Here's an example boilerplate we used in RUBRIC. It's a well-known boilerplate due to RUB and is commonly known as RUB's boilerplate. Let me explain the structure of RUB's boilerplate. Any condition in requirement comes at first, followed by the name of the system or the actor in the requirement. Then the modal verb shall, should, or will. Then there is process which is being carried out in this requirement, followed by the object of the requirement and then any additional details about the object. Here's an example requirement conformant to RUB's boilerplate. The main problem that an automated boilerplate conformance checker must address is to tell the different segments of a requirement statement apart. As you can see over this example, some of the segments are adjoining and come without any fixed elements in between. For example, the tool has to correctly detect the ending of condition here and the starting of the system slot. This makes it impossible to separate the segments without analyzing the constituent natural language constructs. This problem is further exacerbated by the fact that there may be no glossary available or it may be partial. There is a need for a solution that can be quickly applied on requirement set. So it's not practical using deep parsing because it's time consuming and memory intensive. To overcome these problems, we developed RUBRIC tool, which stands for Requirements Boilerplate Sanity Checker Tool. RUBRIC has been developed using Gate framework. RUBRIC used text chunking, which is a robust and efficient alternative to deep parsing. Then there are two functions provided by RUBRIC: boilerplate conformance checking and natural language best practices checking, which is detecting and highlighting potentially problematic syntactic constructs that may cause ambiguities such as passive voice and use of pronouns, etc.
Welcome to RUBRIC Demo. This is the Gate Natural Language Processing Framework. On the left-hand side is the resource browser, and in the middle is the content view of the resource selected on the left. There are three different kinds of resources: processing resources, which contain the NLP modules for text chunking in our case; the language resources, containing documents and the collection of documents called corpus; applications, which contain a pipeline of various natural language processing modules. Let's have a look at our pipeline. Like I said, the pipeline is a series of natural language processing modules, which is run on a corpus containing our document with a set of requirements. Let's execute our pipeline. The document has been annotated by our pipeline. You can see the annotations on the right hand side. The two most important annotations are boilerplate conformant. We show the requirements which are conformant to RUB's boilerplate, and boilerplate non-conformant. We show the requirements which are not conformant to RUB's boilerplate. The requirement analyst might be interested in knowing the possible reasons of non-conformance. One of the possible reasons is that the condition in requirements comes at the end, that is, in the details part rather than the beginning, which makes the requirements non-conformant. Another important annotation in rubric is the condition, which shows the conditional part in the conformant requirements. Now moving on to the second function of rubric tool, that is checking natural language best practices. We generate several warnings for highlighting problematic constructs that could cause ambiguities. First, rubric checks and warns about the existence of conjunctions such as and or. These conjunctions can potentially cause coordination ambiguity, or the use of pronouns, which can lead to referential ambiguity. Another very famous problem in requirements is the use of passive voice, which hides the actor for a particular process. For example, here, when a reported anomaly is fixed, so we don't know who is fixing this anomaly, so the actor here is hidden. Another annotation generated by rubric is the use of adverb in verb phrase. So the person looking at this requirement has no idea what the period is. Is the period a few seconds, a few minutes, or a few hours in the periodically poll? And there are certain vague terms in the requirements which should be prohibited, such as the periodically, which we already saw the kind of vagueness it's causing in the requirements.
That was a demo of rubric tool. Now I'll describe results from an industrial application of rubric tool. We conducted an industrial case study at SCS TechCom with this tool to check results for boilerplate conformance checking. This is the citation of the conference paper for this case study, and you can download this paper from the link provided at the end of this presentation. We used rubric tool to correctly check conformance of around 380 requirements. We used 72 different combinations of the text chunking, and the average precision of checking conformance was 88.6% and recall of 93.4%, and the time taken to analyze requirements on average was 25 milliseconds per requirement. This tool is currently being used by our industry partner, and we received affirming feedback from requirements experts regarding boilerplates conformance checking and natural language best practices checking. To conclude this presentation, Rubric is a flexible tool which can be used for any boilerplate. It saves time and effort for requirements engineers and works effectively in the absence of a glossary. It has been validated through an industrial case study. You can download the installation guide and the Rubric tool from this link. Thank you, and if you have any questions, you can contact me at chetan.arora@uni.lu.